Morning, and thank you for inviting me to join you to present on how to access LiDAR data from the USGS 3D elevation program through the national map and many more applications. Uh, I probably should have checked my title. I'm sorry, Jason, for for giving you a different title than the one that I have here. It is the same content, though, I assure you. And like Jason said, I'm Cyndi Rachol, and I'm the National Map Liaison for Michigan and Ohio. So I would like to start off this morning by saying that for anyone in Southwest and Central Michigan who were affected by yesterday's storms, that I hope you and yours have made it through with minimal damage. I was looking at photos this morning, and it looked like there was quite a bit of cleanup and rebuilding that's ahead. So I hope you're okay. Okay, let's see here. Moment. There we go. Okay, so the mission of the National Geospatial Program is to provide national topographic information to advance science, support government, enlighten citizens, and enable decision making. The NGP provides a foundation of digital geospatial data that represents the topography, natural landscape, and man-made environment of the United States. NGP accomplishes this mission through the acquisition and aggregation of accurate, authoritative data made available and accessible through a series of data and map products and services that we know of as the National Map. Shown here are some of the components of NGP. For today's presentation, I'll give an overview of the 3D Elevation Program, or 3DEP, with a Michigan data update. We'll walk through several ways to access and visualize national map data with an emphasis on LiDAR data. I'll share our newest initiative, which is the 3D Hydrography program, which may be of interest for many of you in this group. And as time allows, I'll share a couple of resources that I strongly encourage you to check out later to make your own custom topo map and to learn at your own pace using national map training resources. The 3D elevation program is our current effort to provide national elevation data with the goal to complete acquisition of national LiDAR with IFSAR in Alaska. 3DEP will provide 1 meter DEMs nationwide with a 5 meter DEM in Alaska. The 3DEP supports a broad range of applications and decisions that depend on elevation data. So a few of those examples are we support flood risk management applications, geologic hazard identification, natural resource conservation, and water supply and water quality assessment programs. So let's start out today's discussion with a quick overview of what LiDAR is. The core data set within 3DEP consists of airborne LiDAR. Airborne LiDAR data are collected from an aircraft using sensors that detect the reflections of a pulsed laser beam. The reflections are recorded as millions of individual points, collectively called a point cloud, that represent the 3D positions of objects on the surface of the Earth. Objects can be buildings, vegetation, infrastructure, the ground, basically anything that is on the surface during that flyover. IFSAR is a type of radar, stands for interferometric synthetic aperture radar. And it has a lower accuracy and is less detailed than LiDAR, but it is the preferred method for data collection in Alaska due to its ability to penetrate cloud cover and operate from planes flying at higher altitudes and speeds, which are good for large collections and remote and challenging environments. Both techniques are transforming mapping by providing highly accurate maps of the Earth's surface and 3D data of all the natural and man-made features that are on the surface. LiDAR data are gathered as a dense collection of points with X, Y, and Z values. Collectively, these points are referred to as the point cloud. The illustrations that you see here portray different features that are represented by point clouds. Part of the USGS's longstanding mission is to maintain authoritative data sets for elevation, hydrography, and geographic names. For elevation, the USGS has maintained a 30 meter and 10 meter resolution digital elevation model for the continental US and 60 meter resolution DEMs for Alaska. Through the use of high resolution LiDAR with IFSAR in Alaska, these DEM resolutions for the nation can be greatly improved. So building the 3-depth national coverage has been accomplished 1 year at a time. This map shows the vintage of acquisition by color, starting with the red in the early 2000s and running through orange, yellow, and green up to this past October. By the end of October, we had nearly 95% of the nation with 3-depth data available or in progress. The even more important thing about this map is that it shows us where new data are needed. And already we are transitioning from to new coverages in areas that we've already have existing data. I can't say enough about this community accomplishment. It's a resounding success that wouldn't be possible without our partners. Our public-private partnership and our 3-depth best resources have attracted partners from across more than 300 tribal, state, local governments, and other organizations. Today, we are distributing more than 52 trillion points, and that's more than 157,000 points per person in the US. In Michigan, we worked with the State of Michigan Center for Shared Solutions within DTMB to complete the statewide LiDAR collection and make it available for public use through 3DEP. The USGS provides a suite of standardized elevation products that are based on those LiDAR point clouds. These include multiple resolutions of our National Seamless Bare Earth DEMs, higher resolution project-based DEMs, and the source data from which these DEMs are derived, such as the source DEMs and LiDAR point clouds. All of these products are accessible through the National Map Viewer, Downloader, and our services, which we'll now discuss in more detail. So to start out with, this is a snapshot of all of the different ways that one can take to access our data. We try to provide access to a wide range of users, anyone from users who may not be map savvy or have access to professional analysis software to those that we'd like to call do-it-yourself experts. So those are those that are writing code and coming up with unique ways to analyze data. Casual users may have their needs fulfilled through our existing cartographic products and pre-made maps, like our US Topo series. We also have many click and play interactive apps for use. And while I plan on touching on most of these today, these three are still in the works and are future applications that our data delivery team are developing. So first up in this whole suite is the national map. The national map includes 8 foundational data layers, which are hydrography, elevation, orthoimagery, geographic names, boundaries, transportation, structures, and land cover. The layers listed in bold are the ones that the USGS is the authoritative source. The remaining layers are built on through partnerships and through standard streaming. Resources are focused on working with partners to build and maintain all of these data sets. Derived products and services, we generate those either automatically or semi-automatically. The LiDAR point cloud index shows where LiDAR data is available, along with the DEM products, and all of this can be viewed through the National Map Viewer. This is very handy if you're not sure what data is available for your area of interest and you just want to take a look without downloading any data. So at this point, I'm going to attempt to take us live to the National Map Viewer. So if you happen to have clicked on that QR code that I'd shown, or you had typed in the address in your browser window, you should hopefully be landing on this page here. I did get a warning earlier this morning that there was a data layer that was being worked on. When you first arrived, you likely had nothing shown on your map. As you can see on the map here, that pops up, there are a list of tools and widgets going from anywhere from being able to print the map that you see on the screen to drawing profiles. But I'll start us out here at looking at the layers list. So within this layers list, you can see all the variety of data layers that we offer on the National Map Viewer. Since we are talking about LiDAR here today, that data can be found in the 3-depth elevation index. When you first open this layer, if you, I've been told these are called twizzles. When you pop on this twizzle and open up all the different layers are nested within, the DEM product index may already be checked for you by default. Again, those are kind of our priority because that's one of our authoritative data sets. And from here, you can see here are all the different resolutions of the national DEM that we are building and supporting. Since right now we are talking about the LiDAR point cloud, that would be under the source data index. So from here, you can click on this twizzle to pop this open, and you can see the different quality levels of LiDAR data that we have within the national map. So if you click this layer and also click on its parent, you should see that populate. And of course, since I'm live, what is not happening? Oh, there we go. Ha! There's a third checkbox that does need to be checked. Anyways, if you click on this next button, this is the legend, so it'll close up our layer list and kind of make this a little bit more tidy. But you can see that, for Michigan, for the state of Michigan, let me zoom out just a little. Okay. Zoom out just a little. I'm using my mouse wheel. You can see the entire state is covered. You can also use these plus minus tools to zoom in and out. You can pan around if there's somewhere else in the country that you're interested in, or you can type in directly in this search box and add either a street address, a municipality, county, whatever name that you want to find. You can. It'll also zoom you in using that. So let's go back to our presentation. Next up is the Elevation Demonstration Viewer. So this is a web application that allows users to view the 3-depth elevation service as either a hillshade, a multi-directional hillshade, an elevation tinted hillshade, a slope map, an aspect map, or a stretched hillshade. So through this viewer, again, you're interacting with the nationwide seamless 1-meter DEM. In places where the 1-meter isn't available, you'll be seeing the 10-meter instead. But we are always trying to stream in through this elevation viewer the finest resolution DEM that we support. So on here, there are tools on this viewer that enable users to overlay contours that can either be dynamic or at you can specify a set contour interval. You can also change the smoothness, so it doesn't necessarily take out the detail, but it does kind of smooth out some of the jagged edges. That's mostly for cartographic purposes. Um, you can also, change the base layer to either be roads or, something else, or change the transparency of these layers. You can also use a cross-sectional tool to draw a profile and, have an idea of what that profile is. And so the important thing here is that I've not downloaded anything. You can, explore the data using a viewer such as this. So let's say you do want to download LiDAR point cloud data. This can be done through the National Map Downloader, and that can be found at the link shown or by doing just a basic internet search for USGS TNM Basic. So from here, you can open up the elevation source data or 3DEP a data set. And you can pick which download product you want to download, such as, since we're talking about the LiDAR point cloud, that is one of the layer sets in this list. So if you were to click the blue show button, that will populate the map. And again, this may look very familiar because this is the same information that we were just seeing on the National Map Viewer. So this here will show you, again, those greens, the different shades indicate the different quality levels of LiDAR point cloud data that's available. So you can zoom in to select your area of interest and select your area of interest using any one of these tools. So you'll draw out either a box or, you can draw a polygon or identify as just a certain point or a coordinate that's on the map. So if you were to click the search button, once you have this area of interest defined, the return will be a list of all available LiDAR tiles. The footprint and thumbnail options, these will display the location of each one of these tiles. And from here, you can either download the individual tiles that are available on each of those links, or you can use the little shopping cart icon to the right of each of these data items to build a queue if there are several files that you'd like to download. So one thing that's important though is to also be sure to note the publication date, because like I had mentioned, we are soon approaching a place in time where we are going to start refreshing some of these collections. So depending on the type of project you're working on, whether or not you might want to to download the same tiles for a specific location and have different dates and see what changed. But it is important and good to take a look at what the publication date is for each of these as you're kind of building your shopping cart to make sure you get the tiles that you're expecting. So once you have your cart filled, you can save the item list as either a text file or a comma delimited file. And so from here, we recommend using the UGET application to download data. The instructions on how to use UGET are a little bit longer than I have time to demo here today, but the link that you see on the slide leads to a very handy step-by-step guide on how to use UGET. So if you're interested in accessing the DMs that have already been compiled and processed, those nationwide seamless ones, or you're just not interested in downloading and storing such a large volume of data that each of these individual tiles will end up being, the 3-depth elevation dataset is available as a service in a variety of formats that can be added directly to your geographic information system. This data is a representation with nationwide coverage that is refreshed every 24 hours. So the most up-to-date data is incorporated automatically. And it not only covers the United States, it also covers all of North America. There are 12 processing templates that are suited for data visualization or analysis already available within this dynamic web coverage service. Many of the templates on this list may sound familiar as they're the same views that were shown on the elevation demonstration viewer just a moment ago. So these steps show how using the elevation services alone in ArcGIS Pro, you can create a nice rendering of a DM using the pre-built templates that are within. So you can do this by layering the elevation service on itself. So here, the elevation service is added 3 times, and then you can go through and repeat the procedure by having one be just the elevation as it's on its own with a hillshade and then a transparent hillshade on top of that to give a shade of relief that gives your map a little bit more pop and adds a little bit of a shadowing effect. So you can use basically the same layer, same data set in 3 different ways and really make your map pop. So going to the National Map Services page and adding the elevation index will also show you a little bit of how our data is organized. The elevation index that here will show all the different resolutions of DMs that are available. I will say there is, in this instance, the 1 meter is available. This is Kalamazoo County. We do have a bug that is in our service. So I will say this weird square in the middle of Michigan, right there is, it's available. But at least for the most part, if you're looking at, other parts of the country, you can see what resolution of DM is available. The seamless DMs are compilations of the most currently available elevation data. So when an updated DM product is published to 3Dep, it's automatically added to our refresh workflow and then ingested into the service on that 24-hour cycle. A new development within this service is that we're maintaining a historical folder if there's interest in viewing the data that has been in the service previously. We wanted you to be aware of this so that if you wanted to step back to a prior version, you can. And this also helps if you're in research or academia and you do want to have that, documentable citation. I accessed the national map and the 3Dep elevation service on this date. You can step back through time and pull that specific layer out. The virtual raster tables, those are found at each of the top of the stage product directories. Um, Oh, and one other update that we did is in the past, if you've accessed our data through an FTP, that has been replaced with a more secure HTTPS. And while this does make it more difficult to download entire folders of data, there is a file at the top of each of our directories called the zero file download link.txt. And so this is basically the same type of file that you would be generating way back in the National Map Downloader, how you're building that cart. Essentially, this is that a cart-like file of the entire contents of within that data folder. Oftentimes, most people don't want all those tiles, but here, in case you did, it's already built for you in one spot. Another way to access 3D data is through the 3D LiDAR Explorer. So by selecting where LiDAR is available, this should yield, again, a familiar looking map. Um, by zooming into an area, you're able to draw an AOI onto the map. And just as before, the results will show all the LiDAR collections that are available in that area. A link to the Rocky web server where this data is stored is provided. However, you'll also need to know a little bit more information regarding the tiles that you're interested in. So once you go into that Rocky Web folder, if you click on that LAS folder, that is all of the different tiles. So here you may not know exactly where each of these individual tiles are within that project. So that is one of the benefits of National Map Downloader is you're inputting your area of interest first, and then it tells you what all of the tiles are within that small box. Here, you're seeing all of the files that are within that particular project within LiDAR Explorer. So some LiDAR projects have additional processing and visualization capabilities. These projects will have a little green icon, this little icon right here, right next to their name. There are a couple of viewer options that allow 3D visualization of LiDAR, either in, 3D visualization of LiDAR in entwine point tile formats. So the first one of these is the POTREE viewer. So again, I'm streaming this data in. I have not downloaded anything, and this is available through LiDAR Explorer. So the POTREE viewer takes you to a view of the data that's set over a black background, which can be maybe a little bit difficult to get your bearings, unless you're very familiar with the area you've selected as an area of interest. So if you expand this little hamburger menu here, it gives you access to a variety of tools that allow for adjusting the visualization of the data by applying filters to the LiDAR point cloud classification or the return interval. There's also an inset map that that shows a little locator that's set over a topographic map that allows the orientation of the data allows you to view what the orientation is of the data and the approximate location that you're looking at. So here, hopefully you might be able to tell this in this little example. This is the Mackinac Bridge. So we're looking at the Straits of Mackinac as though we were looking from standing somewhere in St. Ignace and looking south. So the COPC viewer, the other viewer that's available through LiDAR Explorer, is a little bit more friendly by allowing background imagery to be shown. I know this background imagery looks weird because it's flat, but here you can see, let's see, Mackinac Island over there, and we are, yeah, looking up towards St. Ignace. So we're looking from the south, looking northwards. So this COPC viewer allows for a little bit more filtering and adjustments that are a little bit different than the previous POTREE viewer. But again, both of these allow for visualizing the data through a web browser. So that's before you want to decide if you want to download data or for doing anything further. USGS is currently working with the company that designs this COPC viewer, which is Hobu, to add additional capabilities to this viewer. So if you look in on it now and you say, oh, okay, this is not for me, you might want to check back later. We are making continuous improvements and we're always open to suggestions. So definitely share if you have any. So What's also available through the 3DEP LiDARExplorer is Entwine point tile processing tool. This allows for point tile processing through scripts that are running in the background to do data processing, like reprojecting the data, filtering the data based on returns, or filtering for specific classification codes. You can also you can choose whether you want to see the data as a LAS file, a LAS file, or a GeoTIFF. So this processor helps offset one of the processing steps to the cloud, so you don't have to do it locally. I will say this tool is still a little limited to smaller areas that are 10 square miles or less, depending on the resolution of your source data. So once your data is ready, a link will be provided, like similar to the ones that you're seeing here on the screen. Work is ongoing to keep adding functionality to this tool. So if there are any processes that you're running repeatedly with the data that you're using, please share your experience so that our and cloud team can add it to their user-based function requests. So this is the Entwine page. From here, you can filter everything that is within our 3DEP holdings by project work unit and click on these little blue dots to immediately open either the POTREE or Cesium viewers. The EPT link here, so these dots, I know they just look like dots, but these are actually links. The filter tool is here. If you joined me on this page, you can just start typing. Here you can, here on the page, live version, you can see this is the number of points, LiDAR points that are within each of these collections. This map is also interactive. You can zoom in on this map as well. But this EPT link that it provides the index information in JSON format. So if you're building a custom workflow in PDAL, which stands for the Point Data Abstraction Library, that JSON file can be used to help stream in, the data into your pipeline, or if you are a QGIS data a QGIS application user, there is a way to stream in the LiDAR point cloud directly there using the JSON as well. So for a little bit more information, the EPT data since it is indexing the point cloud data, that was something that one of our friends over at NOAA found very, very useful. And he felt that it was useful enough to write a blog post about it. So if you're interested in exploring that a little bit, you can definitely check out. He does have a very nice step-by-step guide on how to bring that into QGIS. So being able to view this data through cloud-based viewers allows for easy exploration of large amounts of data that we weren't able to view as quickly or as efficiently before. We're usually limited to accessing data on a project-to-project basis and integrating it together from there. So for example, here is the intensity view for for the Tri-County Michigan area. So we're seeing Ingham, Clinton, and uh, oh man, it's been a morning. Ingham, Clinton, boy, I know someone's screaming at their screen right now. Sorry, guys, it's been a long day. Anyhow, the Tri-County area. Looking here, we can also see New Mexico. This helps to quickly identify data gaps across the projects. So this has always been like this here. This consists of 35 different LiDAR projects. So this viewer is streaming in just a massive amount of data. And so keep in mind, right now, this screen view is looking at not quite a billion points, but we were never able to view this much data at one time, and it helps us figure out, okay, where are we missing projects? Where are places that data is needed, or data that should be there is not there? Where is it? So, um, being able to stream, I hope you're seeing the power of being able to look at this data online. Again, not having to download anything quite yet. So another way to access our data is through Amazon with elevation data that is they're basically taking our Entwine point tile formats, um, and they're just streaming that information in. So if you are someone that has access to AWS, you can pull in our POTREE and and COPC viewers, because that's essentially what Amazon is using. COPC is the direction that we're heading in the future of our LiDAR point cloud data. Is a LAS file that has some extra indexing information, which is similar to those entwine point tiles. It gives you the same performance as the entwine point tile data. In the background, EPTs are parsed out with the LiDAR point cloud data into a million tiny files in order to make it more efficient. What COPC does instead is it indexes the points inside of each of those files and saves the index as a LAS file. So that it now turns the data and has it behave similarly to a cloud optimized GeoTIFF. This format is still a work in progress for us as we're working with our data delivery team to include it in a workflow for data that is currently in our production pipeline. So from there, we'll also need to go back through and translate all of the existing data into this format as well. So as you can, with all of the different projects we have going, that is something that is definitely a work in progress. If this format may be of use to you, so please stay tuned. So moving on to open topography. Since our data is available in the cloud now, open topography has been able to access this data and make it available to their users. OpenTopo has lots of custom product generation tools that are already set up. Since this is an NSF-funded effort, the intended user base for the point cloud data through Open Topography is focused on those with an EDU email for research purposes. So if there's anyone here from academia, you already have access to Open Topography, and you may already be an Open Topography user. Um, so let's see. Okay. I believe this is oh no, next to last one for non-USGS applications. If you are a ArcGIS online user, and you may be familiar with the Living Atlas. The Living Atlas does pull in automatically our 1 meter DEM that we have available. So that is available if you search the Living Atlas um, set of layers and you want to bring in elevation. That elevation layer is based off of what USGS produces. So another one is platform is Microsoft's Planetary Computer. So we've taken all of our data and they've taken all of our data and processed it into their own derivative data sets from it. I'm currently not a user of this platform at all, so I won't speak too much more about it, but I'm bringing it to your attention here in case there are users of Planetary on Computer and those that already have access and they want to explore what kind of derivative products they are generating. Google Earth Engine recently made copies available of our 1 meter and our 1/3 arcsecond DEMs. We're told that Earth Engine doesn't handle point cloud data quite yet, although that is something that they are exploring. I wanted to point out these catalogs just in case you're also a user of Google Earth Engine or have an application that could use it in their workflows. So before I leave the topic of 3D and LiDAR to share with some of the offshoot programs that we have using this data, I wanted to share some educational resources that we produce. We have training videos that cover um, step-by-step how to access 3D data either through USGS web applications or software such as ArcGIS Pro, QGIS, or GRASS. We're constantly working on new videos, so if you check these out and have a video suggestion, please email me. I am on that team that is producing these, and while some of these may appear a little old, we do try to keep the information that's within them as current as we can in a fast-moving information age. So, as I had mentioned towards the beginning of this presentation, USGS is the authoritative source for elevation and hydrography data. To give you a little bit of background on this, in the late 1800s, John Powell, who was the second USGS director, assigned the USGS the responsibility to map the topography of our nation. This was accomplished through the use of plane tables and theodolites and lots of field work. And from there, we created paper maps. These maps were created with topo and hydro data that were aligned together. Approximately 100 years later, USGS started creating digital representations of this information. So, however, early on during this early data digital period, we ended up digitizing elevation and hydrography separately. And those ended up being into their own different programs, their own different workflows, and their own different production goals. The two programs were known as the National Hydrography Program and the 3D Elevation Program, which I had been describing for the last half hour. So today, through the 3D elevation program, we now have nearly the entire United States covered by LiDAR with IFSAR in Alaska. And through that data, we are now creating these high resolution DEMs. Now we're able to bring these two data layers back together and derive and align hydrography data using high resolution elevation data as the source. We also want to merge these two programs to get back together again into a single program, which we're calling the 3D National Topography Model. The NHD portfolio of data sets, which has been around for 20 plus years, is the most current and comprehensive data of the nation's surface waters and drainage areas and include millions of features. The majority of the NHD was originally sourced from the digitized stream network captured from our USGS topographic maps. Our strategy for maintaining and improving the data has been to leverage local knowledge through a network of state organized stewards. We have stewardship agreements with 41 states and the District of Columbia. This had been a tremendous effort across a vast network of partners. However, some areas had been updated while other areas have been untouched, and those areas could have data that are 40 years or old, 40 years old or older. This has led to a national inconsistency and has progressively decreased our quality over time because the upkeep in the data set has not been uniform. Additionally, the data does not align well with the new and highly accurate 3D elevation data. Lastly, this discrepancy in upkeep has led to issues with connectivity and the hydrography network with lingering delineation snags in the watershed boundary data set. So this slide here, it really kind of shows a difference in stewardship activities between Michigan and Indiana. Both have been active in updating the NHD and WBD in their respective states. However, Michigan's NHD corresponded to a 24,000 scale data set, and Indiana's NHD corresponded to a less than 5,000 scale data set. The image on the right shows the Indiana border and the Michigan border with the obvious density differences between the two states. This is an example of how two states can have vastly different drainage networks. The USGS wants to avoid these types of discrepancies in the future by, by deriving the hydrography from elevation using the same methods and relying on the same base data. So you may be wondering how we're going to pull all these features out of that elevation data that I just shown you. And we're going to do that by using models of geomorphic indicators. So while flow direction and flow accumulation have long been used to interpret hydrography, they will now be used as one of the many indicators used to evaluate the landscape. With the higher resolution found in LiDAR-based 1-meter DEMs, we're able to use more powerful means for landscape interpretation. These methods allow for the ability to not just evaluate the stream channels and ditches that are found, but also aid in determining where non-channelized features, such as drainage ways and indefinite surfaces, are located. So for Michigan, the state of Michigan has its own hydrography update program that has been in the works for the last couple of years. They are using the USGS specifications as best they can within their program to generate their hydrography. So they're basing it on the quality level 2 LiDAR-based DEMs that you've seen that are available for the state. They divided the state into 3 regions with 28 different work units. All of these regions are along major basin boundaries. They started their data production in the Lower Peninsula and the Thumb region of Michigan. So right now, the focus this past year, 2023, has been lower in the Lower Peninsula, and in this year and towards the end of 2023, they had shifted north into like the Saginaw Basin and further north into the northern Lower Peninsula. So this is a state-run effort. So if you have any questions or you would like more information, please email Mark Holmes. He is the main point of contact over at Center for Shared Solutions at DTMB for that. Um, One other thing that Michigan has done is Michigan EGLE has also contracted with Ducks Unlimited to update the National Wetlands data set. There is open communication between these two projects, so the hydrography project and the wetlands update project to minimize duplication of effort and to ensure there are to ensure that conflicting interpretations of the landscape are kept to a minimum while also staying true to each program's data specifications. So I did include there the link to the Fish and Wildlife Services project page, so you can click on that link and check out each of their different project areas. So a couple of insights. The next two slides are slides that I had gotten from received from Mark, um, on what they're seeing in their hydrography update. So as you can see here, the former NHD or the existing NHD data set is shown in green, and then the new flow lines, which I know might be hard to see because there's some shadowing, are these dark bluer flow lines. So with the improved high resolution DEMs, they are able to get far more detail in that flow line connection and not have some of these oxbows kind of cut off. What they're also seeing is that the same thing. So here's the digital elevation model, which you might only look at the image, the aerial image, and you may not see this as clearly as you can. So that's also one of our reasons we want to be able to have a set data source. Imagery does change quite often through time and depending on when you collect it. With the elevation data, we're hoping there isn't a whole lot of changes in these landscapes and that those changes are occurring slower through time. Next thing that I want to highlight and tool that I want to show you is our Topo Builder application. Topo Builder is an application that lets you build a map that's on demand, where you want it to be within the US and the territories. You can choose whether you want it in geospatial PDF or GeoTIFF formats, and it is always using the best available authoritative national map data. So I'm going to run a little demo. So I will pause here for anyone that wants to follow along. When I give the Topo Builder presentation on its own, people do end up getting their maps before the end of the day. So if you want to follow along, I'll just pause for a moment. And then let's see, where is my browser? Okay. So here we are. So if you opened up the Topo Builder application, you will see something that looks just like this. Topo Builder right now supports both the 7.5 minute topo and the 1 to 100,000 topo. So for this demo, I'm just going to click my 7.5 minute and click next. So from here, I'm going to zoom in to an area of interest. Let's come over here, Lansing. And as you can see, maybe you might be able to see it. There's like a blue box that is kind of centering around my mouse here. So this blue box is essentially the cutout for my topo map. As you can see here, here's the map index. So if you are familiar with the USGS 7.5 minute series, these are all of our existing maps. So you are more than welcome to pick a map that's exactly over, and what it's doing is it's pulling the newest, latest, and greatest data for that map. You can also click on anywhere you want, and it will have your map now centered there. So so now I have a test map picked. I can now customize it. So from here, I can choose what format I want it in, PDF or GeoTIFF. I can say what contour smoothing I want. So here, the little information button that I clicked on, it kind of describes what the difference is between low, medium, and high smoothing. If you're a fan of our existing Topo Map series, the medium smoothing is what you generally get, and that is also what's default here. So I'm going to keep that the same. Here I can also choose what layers I want in my topo map. So let's say I have no interest in knowing where all the roads are. I'm going to turn that off on my topo map, but I want to focus on hydrography, wetlands. I want the terrain on here. So close that up. I want the terrain on here. I do want land cover. I do want some boundary data. And the ortho image is something that um, does come in by default. You can also say, hey, I don't want that. Um, so for here, you can turn layers on and off. You can hit save. And then for here, you will have to actually say, I want this map in order to add it. So right now, it is just assuming that I'm kind of playing around and making a bunch of different maps and setting a bunch of different areas. So as you can, I just clicked somewhere else. I did not click this box, so I have nothing added to my cart just yet, but I can go through and, click a bunch of maps. And as you can see here, it keeps building. Here's my original one. I can change one to high, another to low. So again, you can customize these. Um, but then whatever you choose, you add, into your cart. So I'm going to build my cart here. I'm going to add all those. If I want them, you can say later on, oh, geez, I don't want that one at all. I'm not interested in it. But anyways, here I have all four of those maps selected. I can either go back and select more maps and go map happy, or I can check out. You check out, it wants you to enter in your email. So I'm going to enter in. And my email I will give at the end of this presentation for anyone, if I can type. That would like to reach me after this presentation. So from here, hit checkout, and you will see this little, your request has been received or has gone into our queue. So I know here it says they're often delivered within 24 hours, can take up to 5 business days. We kind of put that disclaimer in because sometimes we do pull these services down so that we can make some improvements or fix some bugs that users report to us. Um, but from here you can close. You will receive two emails. The first email will let you know that, hey, this is what you ordered. The second email that you receive will include links to all of your maps that you had requested. And from there, those links are live and you can share them for, I believe it's up to 60 days. You can share that link with your friends, family, coworkers, whoever you want to have a link to that map that you made. Let's see. So going back to my presentation, if I can find my slides. There we go. Okay. So thank you. We've reached the end of the presentation. Here's my contact information. I went through a lot really quickly, so please contact me if you have any questions or you have some suggestions for tool improvements or if there's anything about the National Geospatial Program that I could potentially answer for you. And how am I doing on time? Oh, wow.
You're doing great.
Okay.
First off, thank you so much. So to all of the attendees, at the very bottom of your screen, you should see a Q&A button. So if you have any questions, please click that button and type in any of your questions. I did get one direct question to me. Would
Sure.
you be able to share these slides? Um, like you could like if you're able to send them to me, I can send them to all the attendees, or if somebody contacts you, are you able to share these slides?
Yeah, I can share a PDF. I know there was quite a bit of QR resources and links that were in there and some of those, the ones I didn't include a QR code for, I think there was only one that was non-USGS. So yeah, I'd be happy to do that. I think all of this is public information. So
Okay, perfect. So we did get a question. Um, does USGS fly all of the LiDAR or do they compile from different sources?
That's a great question. So we have data that can make it into 3DEP in primarily two different ways. It can be either a partnership program that is, partially funded by USGS and contracted through USGS. And, so at that point, USGS will either, we will hire a vendor to collect the data, or we will, work with our partners and the partners will hire a vendor to collect the data. Most of the data that you see from Michigan, when I say that we worked with the state of Michigan Center for Shared Solutions, they actually funded the collection through their own partnerships, either with state money or working with counties and collectively collecting the data that way. And then one of the things is we serve the data to the public. So they wanted to contribute their data into 3DEP because at that point, the state of Michigan doesn't have to serve this data to the public. So that is the other avenue that data can make it into 3DEP is it's a contributed data coming to us from one of our partners. I will say that any contributed data set, though, it still is expected to go through our data quality uh, review process, just as though that it was one of our contracted projects. And the important part is we do that because we want to use the data for our own DEM generation. So it needs to meet those standards. But then also when we're putting data out to the public, we want to give the public assurance that the data has gone through some of those review checks and has been vetted.
Awesome, thank you. Next question. Can you
Sure.
explain what an arcsecond measurement is?
Oh, sure. So, if you were to, I don't know how many people remember globes, but if you remember a globe that is, uh, you know, that 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 boy, that orb representation of the Earth, on the globe, you would have each of those lines that would be like a longitude line, and as you kind of spun around that globe, you would have the zero longitude line, which would be the prime meridian. Um, and from there, each line that is going around the globe, that is that is an arc. So that each the Earth is divided round into 360 of those. So each arc second is that width, if I'm explaining that well. It's kind of an antiquated way of viewing, I guess there's because no one really thinks about that we're walking around on a round object. So that's why often you might see the 1 meter, sorry, the 30 meter, uh, the one arc second referred to as the 30-meter DEM. That is also kind of another way to call the 1 arc second DEM. I'm not explaining this well. I know it, and I apologize.
No, it's totally fine. So
Yeah,
essentially, is it like a conversion between like arcsecond and meters? Like, is there an easy conversion between the two?
I'm sure there is. I can't think of it at the moment. And
Okay,
I can find that answer and get back to you. Yeah, because that's something that again we don't really use anymore in our in normal day to day and how we talk on representations of the globe of the Earth. I know we
gotcha,
use it here because that's I guess in one of our historical ways, but the 30 meter is the one arc second data set.
gotcha. Two more questions. So,
Sure.
uh, does the viewer have a preferred browser? Does the browser work? Does it work with Mac or Safari, or is there something else that's better to use, like Chrome or Edge or something like that?
Yeah, I know that it should work across all browsers. Um, I know some people have had issues with Chrome, so in fact, most of the work I do is in Edge just because I run into less issues. But I don't have a specific list of known bugs on of use with Chrome. And as far as I know with Safari, I believe it should be supported just as well.
Gotcha. Um, Last question we have so
Sure.
far is the data readily available to use within QGIS? And if you have any tips for using that?
Yeah, yeah. So I did have a slide on bringing it into QGIS, but I took it out. But one thing I will say is, if you did follow that link to that the blog post from NOAA, they do have good step-by-step instructions. On the video team side, we are working on a video on how to use 3D data within QGIS. So, it's I'm hoping that'll be out there by this summer. So I guess stay tuned on that. But yes, this data is available in for use within QGIS, especially if you're using the services. And but then you can also stream in the point cloud data as well. It's under you'd have to go through the JSON so that that entwine link that showed those all those little blue dots. You find, whatever project area you're interested in, and then click that JSON link. That will pop up in another browser window, and it's that JSON address is what you want to use to stream in under add layers in QGIS. So I hope that makes sense if you're a QGIS user. Hopefully you might be have QGIS open right now and they're saying, "Oh yeah, there it is." But email me and we
Perfect.
can set up a Teams and I can, you know, you show you on screen. So
Awesome. Well, thank you so much. That was all the questions we have. And thank you so much for your time. If you want, Cyndi, you can email me the slides or like a PDF and I can figure out a way to get it to all the attendees.
will
And
do.
thanks everybody for attending.
Yeah, thank you.
Awesome. Have a great day, everybody.